And with number 8, a company distributes college logo sweatshirts and sells them for $50 each. The total cost function is linear, and the total cost for producing 100 sweatshirts is $43.60, whereas the total cost for 250 sweatshirts is $70.60. So this looks like an instance where we're going to have a revenue and a cost, and we are asked how many sweatshirts must the company sell to break even. So we will go ahead and get started with our revenue function. So remember, revenue is equal to price times the number of units sold, which in our case is going to be X. So we can say that for this product, revenue is going to be $50 because that's what they're selling it for, times X, which is however many of these sweatshirts they are able to sell. Now for the cost function, it's a little bit more involved. We do have 2 points, so we need to use point slope form to figure out a cost function. So we'll go ahead and get started with that. We do have 100 and 43.60 as 1 point, and 250, 70.60 as the other point. We know we need a slope, y2 minus y1 over x2 minus x1. And so label your points, Schlegel. You got x1, y1, x2, y2. And we're going to get y2 minus y1 is 70.60 minus 43.60 over 250 minus 100. So in Wolfram, we're going to go ahead with our 70.60 minus 43.60 divided by 250 minus 100. And we end up with a slope of 18. So now our point slope form, y minus y1 is equal to m times x minus x1. And we get y minus y1 is 43.60 is equal to our slope, which is 18, times x minus x1, which is 100. And so we do want to go ahead and get the alternative form of that because we prefer that. Y minus 43.60 is equal to 18 times x minus 100. And from Wolfram, we get the alternate form right here of y equals 18x plus 25.60. Okay, and so we are asked how many sweatshirts must the company sell to break even? And so it's important for us to remember that this is our cost function. So I'm going to go ahead and change that y to a capital C so that I remember that this is the cost function and that up there is the revenue function. One thing that we can do, everyone, is remember if we're trying to break even, we can set cost equal to revenue. So break even occurs when cost is equal to revenue. So we can set these two equations equal to each other and see what happens. So that would be 18x plus 25.60 is equal to 50x. So we've got 18x plus 25.60 is equal to 50x. And we end up with 80. So x is equal to 80. So for part A there, the company must produce and sell 80 sweatshirts to break even. And for part B, we're asked to identify and interpret the meaning of the slope and y-intercept of the profit function. And so in order to get a profit function, everyone, we need to remember that profit is equal to revenue minus cost. And so we can use our revenue functions and our revenue function and our cost function up here to fill that in. So we would have profit is equal to 50x minus, and remember to always put a parenthesis there, 18x plus 25.60. So in Wolfram. We could do the 50x minus 18x plus 2560. We end up with a profit function of 32x minus 2560. Okay, and so if you've kind of been going through these lessons with me, everyone, as I hope you have been, you would recognize that that is the marginal profit, which means how much profit we will make from producing and selling one more. And oddly enough, in the profit function right there, we see the fixed costs. And so the fixed costs of just starting to make these sweatshirts is going to be, it's going to cost us $2,560 just to get going making the sweatshirts. We were asked about the marginal profit here, though. Marginal profit is $32, meaning that for every sweatshirt that is sold, we make a profit of $32. So there you have it, everyone. That is everything for problem 8.